Well, welcome everybody to our metaphorical roundtable. It's hard to get a real roundtable of this size. This is the 10th annual Lorne Trottier Public Science Symposium. And Lorne, as you well know, is passionate about science and about doing science properly, and has graciously funded this now for a decade, which is really quite a spectacular achievement. And we've in past years dealt with a number of interesting topics ranging from pseudoscience to alternative medicine. And this year we asked the question of whether or not we are alone, which is, of course, a question that I think all of us have asked ourselves at some time in our life. The idea behind the roundtable session is to have a pretty much of an informal discussion with our speakers and some members of the press and some of our faculty, and ask questions and discuss interesting issues. I don't want to take a lot of time doing introductions, but I think we will just go around the table with just a one or two sentence introduction, so that at least the audience who will be watching, because this of course is being recorded for the vast worldwide audience, and it is actually more vast than you would think, because we have had over the years thousands and thousands of people viewing these sessions around the world. So we do have an impact factor here, and although it is informal, people do watch it and they do learn from it. So first of all, let me welcome our four distinguished speakers, and they come from distances far and near. And I will not go through all of their elaborate histories, because we are somewhat short in time, but I will give just a touch of an explanation to know why it is that they are here. Jim Bell comes to us from Arizona State University. He's also the president of the Planetary Society, and gives lots of talks on issues about planetary science, and is an expert on Mars and has been very much involved in the Mars rover, guiding it, climbing mountains with it, whatever. Sarah Sager comes to us from MIT, and she's a top-notch expert on exoplanets, the planets that revolve around stars other than our own. And we'll be hearing from Sarah in the symposium tomorrow night. Jim will be tonight. Joe Nickell is an investigator of mysterious phenomena, everything from haunted houses to UFOs. He's written numerous books on the topic. He's a much sought-after public speaker. He publishes regularly in the Skeptical Inquirer, and is a skeptic known around the world. And skeptic, of course, is not a dirty word. A skeptic is just says someone, okay, I'm ready to believe, just show me the evidence. Then we come to Jill, and Jill Tarter is well known to many people around the world, basically because the famous movie Contact, starring Jodie Foster, was in a sense modeled on Jill's career. She was one of the founders of SETI, the Search for Extraterrestrial Intelligence, and she's still searching for extraterrestrial intelligence. Maybe it will be found soon. Who knows? That's one of the things that we're going to discuss here. Then they're very quickly going around the table are our panels. Julie Payette. Julie is well known across North America, having been an astronaut and having been up there twice, the only one around this table who has seen the Earth from afar and can testify to the fact that it is round. Yes. Vicky Caspi is physics professor. She's the Lorne Trottier Professor of Astrophysics here in Montreal, also a world expert on exoplanets, and of course will be a major contributor to this discussion. Bill Brownstein is one of Montreal's best-known reporters, works for the Montreal Gazette, and writes stories on all kinds of interesting things, and has a very inquisitive mind, especially when it comes to finding the best smoked meat in the city. René Doyon comes from University of Montreal, also a professor and expert in planetary science, and will obviously have a very sound scientific background to this discussion. Karen Seidman is the education reporter for the Montreal Gazette. Universities reporter for the Montreal Gazette, which is, of course, our local newspaper. Boswell Wing is a professor here at McGill in Earth and Planetary Science, and is an expert on the exploration of isotopes in the ground and the information that they yield. And Provost Massey is the provost of the university and is interested in everything, right? Which is why he's here, and Lauren, of course. But I'll ask Principal Massey to actually give an official welcome.
Acting principal this week.
Are you really? Yeah. Yes, she's away.
Well, good afternoon, everyone. And as the provost of the university, I'm delegated by the principal to be the chief academic officer of the university, which means all of the deans of all of the faculties report to me. I'm also delegated to be the chief budget officer of the university, which means all of the deans are nice to me. So that at least gives me something to look forward to when I come to work. But these symposia for the last decade have really been the highlight, I think, of my career as an academic administrator. Their outreach to the community, the ways in which they bring people together to talk about significant and interesting, important problems, the way in which they approach the skepticism of many people and the lack of evidence is a really important teaching tool that is used for these symposia. It starts with an important question, and then it uses scientific method to try to arrive at a satisfactory answer. Sometimes there isn't one because there isn't evidence. Certainly, Are We Alone is an important topic, not only because it's popular in terms of science fiction, science fantasy, and Hollywood movies, which is an important thing to bring some consciousness to people, but it's also important because it raises fundamental questions about what we're really looking for. What is the life that we're looking for? So it's really wonderful to have someone who looks at a planet close to ours on the panel to help us understand the ways in which life in extremes might actually occur. It helps us to understand something about an emerging field like astrobiology. It's wonderful to know I used to turn my screensaver on to the SETI project to allow my computer to be used to try to find things that aren't there. I think it's also really important to have people addressing these issues from the point of view of science, whether skeptical in terms of the evidence that's drawn, or finding other systems that look like ours. So the panelists are a wonderful collection of people to help us address the 10 provocative questions that Joe and his team have put together for us. And with the support of Lauren Trottier and his family foundation, we have now put in a decade of time into developing this symposium into a highlight for not only McGill during the year, but also for Montreal, and increasingly across the internet and World Wide Web to the world. So I'm pleased to be here. And even though I'm only a demographer, I count people instead of planets, I'm happy to be here, and I will, if given an opportunity, participate. Thank you all for being here.
Okay, well, the questions that we put together are just questions that I thought would be interesting to discuss. Obviously, if anything else comes up, open for discussion. And certainly would ask anyone to pipe in whenever, but I think to get things going, the Drake equation, I think, is one that would be a very good starting point. And I think Jill will get this one going, because we talked a little bit about this, and I know that you have some views on the interpretation of the Drake equation in the movie Contact.
Well, the Drake equation, for those of you who may never have heard of it, is an attempt to estimate the number of technological civilizations in the Milky Way galaxy with whom we might have communication. Okay. Having said that, it's a much better agenda than it is an equation, right? And that's what it started life as. It's a way to organize our ignorance about this topic. There are different factors, starting with the rate at which stars are formed in the galaxy, what fraction of those stars might host planets, and how many habitable planets there might be on average in a planetary system, what fraction of those habitable planets evolve life, which life forms evolve intelligence, which intelligent species develop technology that could be used to communicate, and finally, the most important and unknown term, how long that technological civilization continues and how long communication is possible. So we know a lot more about the front end of the equation, star formation rate, the fraction of stars that have planets. We've learned in the past couple of decades, since 1995 when we found the first planet orbiting a main sequence star, and now are into almost 5,000 exoplanets or exoplanet candidates. We know a lot more about that. We now think every star has planets. But how many of them have life? We don't know. What fraction of life becomes intelligence? Really, really hard to figure out with an example of one that is life as we know it on this planet. How many technological civilizations form out of intelligent species? Again, it's a guess with an example of one. It's really, really hard to pull apart the necessary from the contingent. And finally, how long do technological civilizations last? You know, we've got maybe 100 years in the game, if you talk about electromagnetic radiation and broadcasting signals. Galaxies, 10 billion years old. So we're a real young technology in this old galaxy, and we don't know whether it's possible to become an old technology. I think that's the main question that SETI is focusing on. That's one of the really important pieces of information SETI could eventually provide us with. So, great agenda, wonderful thing to talk about, but we really shouldn't ask students to calculate anything with this. It's just guesses. But it's a good thing to consider.
Comments?
Well, I would say that, we astronomers are working on the front end of the Drake equation, trying to find the prevalence of habitable planets among stars. And what is exciting is that we're very close to actually get that number. We already know that there's lots of planets out there, and rocky planets, and we're really down into the details of getting what fractions, the uncertainty of these numbers, and as a function of mass. So we're getting quite a lot of details, but as you mentioned, this is the last part because it's more tricky, how long a civilization lasts, and whether life actually just gets to start as easily on Earth. That's the big question.
Right, and so there's a question of habitable and inhabited, and getting across that question is a one that's requiring a lot of technology development, whether or not we may find biomarkers on other bodies in our solar system that indicates life. And of course, if we find a second genesis of life in this one solar system, it's everywhere. Right?
Yeah.
But when we talk about looking at distant planets around other stars, for now, biosignatures, indication of some biology, that's a real hard challenge. We'll start by looking where it's easiest, the stars that are closest to us, but that may not be the best place to look. That's one that's going to be driven by technology and our capability. But since I'm interested in the mathematicians rather than the microbes, right, it's possible that we're going to answer the question of, is it habitable or is it inhabited, by virtue of hearing transmissions from the technological inhabitants.
This discussion always comes up whenever Jill and I are in the same room, probably with all the other exoplanet hunters also. But until that time, we are trying to make the first step, because if we find some signs of life on many planets, we then believe that there will be intelligent life somewhere else. So hopefully we'll hear from them first, but until that time, we're here to help assess.
We're both happy for either microbes or mathematicians, right? Either way, phenomenal discussion.
But what you're not happy about is the amount of money available to do the search, correct?
That's correct.
So, which I think is a nice segue to the second question here, is about funding. And this is something that is in many circles controversial, about the amount of money that is being spent on the space program. some people argue that it's absolutely essential, others say that it's a waste of money.
Well, I think I like the way that you phrased the question here, talking about the investment in the 60s when it was a nickel for every tax dollar, and now it's down to a penny. First of all, most of the audience is going to think it's much more than that. Most people think that we invest a huge fraction of our budget in space research, and that's absolutely incorrect. I think that from my point of view, if we go after something like SETI, which is really inexpensive, we could learn that it's possible to survive our technological adolescence, and we could get on with the process of solving the problems that look to us like maybe they could end civilization within a century. So seeing ourselves in a more cosmic context, seeing ourselves as all the same, seeing ourselves as having to work globally to solve problems, I think is one of the things that space exploration brings to us, and SETI as well. In talking about stepping onto the moon, and what the whole Apollo program was about, I love the quote that talks about the most valuable thing was giving the average person on the planet a bigger view of their universe than they usually get from their back porch. So.
But Julie, I'm sure you have something to say about funding of the space program.
Oh, I do. Besides the question whether I've seen extraterrestrial, which I get all the time, believe it or not, is the second one, or the second most asked question is well, what could we do with all that money that you put into space exploration, particularly manned space exploration? Would it be better used here on Earth to solve real problems? So that because people don't have a good appreciation of the small percentage that is devoted to R&D, research and development, basic research in general, let alone space exploration being a small part of that. There's a lot of that misconception, I think, comes from the fact that when you look at the amount itself. So the James Webb Telescope is a very big endeavor, and it will allow us to bring our knowledge even further forward than imaginable. If you look at the price tag, it's extremely expensive if you just look at it. But in the context of the partners and the promises, it's a really small investment to progress. So the way I usually tackle this is that I say that any society is a product of its past and needs to know it, is a product of the present, who they are, what they are interested in, and how they manage today, and they are going to continue forward into the future, and they need to prepare for that too. So if you put all your eggs in the same basket of the present, you're not going to go very far. It is also, I believe, the job of institutions and bodies that can raise taxes to in particular fund what we call the unknown, that we don't know. You can't ask a small enterprise with a small operation budget to invest millions of dollars into a question that we're not so sure if we're going to answer today or tomorrow, but it is absolutely fundamental, though, to explore.
Actually, Julie, I think you're the only one who has actually seen extraterrestrials, because the astronauts who were up there with you were extraterrestrial.
But I actually use that phrase a lot when I'm joking. You know, sometimes I say something really silly and people look at me like I'm an extraterrestrial, and I say, yes, I am. For 25 days, I was. And no, and I met several others, but they were all in the same vehicle with me, and I was not abducted. No, okay, but it's playing on words. I think it's fundamental that it be maybe better communicated, that budgets are really small, but are absolutely essential for our future. The budgets and basic research.
I personally have been a space enthusiast all my life, and I would dearly love to see the budget for NASA and the Canadian Space Agency to be increased substantially. But I would also say that there's some promise with some of the private ventures that are coming forward, like SpaceX, who, if they succeed in what their stated goals are, could drastically reduce the cost of this technology. And we wouldn't have to be worrying about how much we're spending on it. The cost would come down. But despite that, I still think we should be spending more on it. I think it's very worthwhile.
To support that point, I'll say that even now when we go through our costing exercises and we think of the SpaceX launch vehicles, really it's cheaper, it saves us money. If they can certainly reach their goals of the cost to get to space, it will revolutionize what we can do with space astronomy. I want to add a comment to all these things, and we can sort of argue about the budget and how much we think should spend on it, but there's one point that hasn't yet come up. And actually in exoplanets, we have a term for it. We call it the awakening. And what we've started to see is that all around the world, from the Vatican, that was a meeting where I saw Jill a few years ago, to the United States Congress, who wants to hear from us, us like reporting to them. There's been this sort of awakening that with exoplanets and the search for habitable worlds and the near-term search for microbial life, that it's really accelerating. And so the interests of the world and the public is so huge now. And I'm sure for all the other people here who get fan mail on this topic, it comes from like the smallest child who can write to literally women in their late 80s, their late 80s, who've been interested in this topic their whole life. So one of the arguments we like to use is that by promoting this field and investing in the search for planets that might be like Earth, we're helping our future, the next generations enter in technology, and to actually want to they won't end up working on exoplanets or the search for life, but to help, our nations stay very strong in that regard.
Aaron.
Yeah, I was just going to say that I think in a time of limited resources, it's very easy to say cut back on these things to the average person. I guess it seems perhaps not that essential, but I mean, I think space exploration is about aiming high, and so if you're not going to fund it fully, then you're kind of going for mediocrity. So I think it's about pushing and striving, and it's great for the scientific community to have that opportunity.
Yeah, what I'm taking from this is not so much the comparison with what we were doing in the 60s, but how little we're spending now, and the huge progress we're making with that. So I think it's a very important message because you always get this question, so why are we doing this? Why are we not putting money in medicines? But you have to make the argument that, as Sarah said, you're pushing technology to the edge, and in a few decades later, you're using that technology for saving lives. Medical imaging, and people don't know that.
I think it needs to be pointed out that money that is being spent is not floating up in space. I mean, that money is being spent here on Earth.
Absolutely.
Right, giving jobs to people and giving research programs. The raw material is actually nothing, right?
Yeah, another analogy you can make with the space program is, for example, in particle physics, where they build huge colliders and smash tiny particles together, and people wonder, well, why would you spend so much money on that? But if you look, it's the physicists in the end who, because they needed to transport huge amounts of data around, invented something called the internet, which, of course, is huge for humanity. And so to say that it's better spent on earthly problems, I think, misses the point that it actually solves a lot of earthly problems in ways that you never could have imagined in advance.
Right.
So I've had a number of acrimonious interactions with the United States Congress about funding for SETI, but I have to say one of the lowest points ever, and you can go find it on C-SPAN, is to have a member of our Congress stand up and say, we can't afford curiosity. End of story. I think that's such a sad comment on where we are. And curiosity is the thing that we ought to support. It's what drives us. It's what's going to lead to everything in the future. We can afford curiosity.
Well, curiosity takes us to Mars.
It does.
Yeah, it certainly does. Okay, and also it takes us to the next question about the getting to Mars and who should be there and whether it should be more than the rover, should it be humans? And obviously, you're the one to get that ball rolling.
Sure. Well, first of all, thank you for the invitation, Lauren. The things you do for this university and this community and the world through organizations like Planetary Society are amazing. So thank you for what you do. This is an interesting question, and people have been asked to compare what we could do with humans on Mars to robots on Mars. And I basically try to divert the question to something that is maybe a little bit more visionary, because honestly, it doesn't really matter whether NASA or whoever. Some people are going to go to Mars. It's going to happen, and I don't know whether it's going to be NASA astronauts or Canadian astronauts or SpaceX employees or Chinese astronauts. Who knows? It's going to happen, and just like we went to the moon, it's potentially not going to happen for science. It may happen for geopolitical reasons. It may happen because, like we've been talking about, space exploration is a provider of intangibles for nation states, inspiration, knowledge, education, national pride. So if we accept, which I do, that it is going to happen sometime in the next 1 to 3 decades, probably more like 3 instead of 1, then how do we get the most out of it? And the way to get the most out of it is to have a very active program of what we can do now, which is the robotics. Our robotic emissaries are, finding out what the environment is like, scouting, doing the basic remote sensing, characterizing the current climate, the topography, the geology, the mineralogy, all of the things that you want to do before you send either more sophisticated robots or the ultimate sophistication, human beings. And so in my mind, it's not a question of whether humans or robots should go to Mars. It's a question of how can our robotic colleagues, if you will, help the eventual people who are going to go there in our lifetimes. It's going to happen.
Is bringing samples back from Mars first step?
So it's pretty widely acknowledged that we need to know more about what that environment is like, the effects of radiation, for example, on humans and equipment, the effects of micron-sized dust grains on humans and equipment, the possibility of there being strong oxidants in the soil that could interfere with certain kinds of materials. There's lots of sort of technical reasons to want to have some of that material in hand. And it turns out that for the near term, the foreseeable future, it's just much more economical to go get some of that and bring it back to our laboratories here than to build the laboratories there. That's one part of it. And the other part of it is, and we'll touch on this more, we are actively doing this search for habitability and even inhabited environments on Mars today. And it's likely that, Jill mentioned biosignatures, biomarkers, it's likely that in an environment like Mars, those biomarkers could range from the macroscopic, seeing something walk across a camera picture, which we haven't done, or fossils, which we've never seen, but we look, to signatures that are much more subtle. Subtle chemical variations, subtle isotopic ratios. And it's likely that if we were to find a biosignature on Mars today, it would be on that more subtle end. It's an ancient environment that's been heavily degraded by weathering and ultraviolet and cosmic radiation. And if that were the answer that we got, it's like this subtle isotopic ratio may indicate the possibility of a fragment of an organic molecule. That would be endlessly debated. Nobody would believe it, because the equipment there is so much less capable than the equipment here. So in order to get people to believe it, ourselves included, you've got to bring that material back and study it with the best facilities you get.
Oswald, I'm sure you have something to say on that, because you do that kind of stuff here. You'd love to get your hands on a handful of Martian soil, right?
Yeah, well, maybe not soil, but certainly some of the right types of Martian rocks to look for the isotopic variations that Jim was talking about, which are usually produced by microbes. And the fact is they discriminate very slightly against one metabolite that might be slightly isotopically enriched and produce a waste product that's slightly isotopically depleted. And if that fossil record of that metabolism is actually found, it would be phenomenal. And we can detect it. I mean, these are variations that are on parts per thousand or even smaller. And in the labs on Earth, it's almost routine to detect. But to build a lab on Mars, I don't think Curiosity quite got there this time around.
That was a great expense and great effort to get where they are.
Now, how would you get that notion across to the general public, to a lay person on why it's important to look for isotope ratios, why that means something.
Well, everything eats and everything excretes, right? And so the isotope ratios really monitor that process. And if they're preserved in such a way, you can say you've got a fossil record of that energy generating process, let's say.
But do you need a sample return for this, or can you send a good robot out there?
We can definitely do it better on Earth now. And so if the robots are going to be what will bring the samples or help us bring the samples back, then let's do that. Because like Jim was saying, the environment there is so tough, let's say, for the types of instruments that we need. Basically, here's a really good example. You need a vacuum pump the size of a beer keg to create the right type of environment to do these analyses. So getting that would require a lot more new technology.
My point is that you can probably do that with robots. And that money would be better spent doing it that way than trying to send humans over there, which is
well, I think the human
expensive.
the human angle is going to be in terms of finding the right samples to bring back. So sending as a scientist, sending a human to Mars, what you would do is you'd want to send somebody who has a geologic background, who has this capability of hypothesis testing every time they see a new rock. And I don't know if we're able to build robots that can do that.
No, and even on our own planet, where the early record of life from the Precambrian is preserved here in places. They're very special places, and it takes extremely trained people to find those places. And they're making very delicate measurements, sometimes right on the fringes of a yes/no answer. And they're using not only hypothesis testing, they're using gut instinct in many cases, just from their experience with our planet. And these are things you cannot program into a computer. I just want to I'll add one more dimension to this, okay, because we talked about Mars, but I think we need to talk about Europa as well. Because Europa is a place where I believe, and I think many of my colleagues believe, we could be talking about extant microorganisms in that environment today.
Just explain what Europa is.
Europa, large moon of Jupiter, has an icy shell, but it's affected by the tidal forces of Jupiter and the other satellites nearby, that it squeezes and heats the interior of Europa, and so it's widely accepted, although not proven, widely accepted that there's a very deep, extensive ocean of salty liquid water underneath that icy shell, hypothesized to be 2 to 3 times the amount of ocean water on our own planet. It could be the largest ocean in the solar system. And at the bottom of that ocean is a silicate solid rocky body, like in the bottom of our ocean, that is geothermally heated. There could easily be, black smokers and hydrothermal vents and ecosystems down there. It's very easy to imagine that as an environment where life could exist today, and not perhaps like on the Martian surface, shreds of something left from long ago, but real life there today. So that's an important priority for NASA and other space agencies as well. Much more difficult to get out there, much more difficult to operate.
In some sense it is, Jim, but I always look at Europa as maybe a free lunch, or a bit of a free lunch, because like Enceladus, a tiny moon of Saturn, we have these cryovolcanoes, these plumes that are being ejected. And so in order to sample the ocean beneath the ice, perhaps all you need to do is fly through those plumes to capture the contents.
Yeah, I hope you're right. I mean, we don't know for a fact that study is correct, and then the Hubble Space Telescope is working really hard this fall to try to prove that. I hope you're right, because that does open a lot of doors. The problem with working in Europa is it's inside this enormous radiation field of Jupiter, and it just wants to fry your electronics and your astronauts. And so the less time you can spend there, the better. So just flying through the plume, scooping some things up, bringing them back, or analyzing them for multiple flybys, that might be the best way to do it.
Well, so far, of course, all this is very technical stuff, and this is what is discussed in the scientific community, but the lay people out there learn a lot, or they think they learn a lot, from TV, radio, and newspapers, etc. Much of which, of course, is mythology, which takes us to Joe, because he does a lot of investigation of what is fact and what is fancy.
Well, people have already determined that there's extraterrestrial life, and it's visited the planet Earth. It's evident in all these UFOs and alien abductions and so forth that I deal with all the time. When I show that I'm a skeptic, people say, if I question a UFO sighting, people say, well, don't you believe in life out there? And as if it were the same question, but I think it's really a pretty different question. I mean, I'm a skeptic who's quite willing to believe that there must be life somewhere because of the odds, but I'm just skeptical that it's visited the planet Earth, which is a whole different issue. And I'll talk about that tomorrow night. But the abductees, Betty and Barney Hill, I see as a question on down here, but of course they bring us the happy news that not only have extraterrestrials visited the planet Earth, they look just like a futuristic version of us. Isn't that a wonderful, wonderful arrangement? And it's very obvious that we're creating these things in our image, and that we're believing things out of our own desire. One of the things I'll talk about tomorrow is how here we are on this lonely planet, which is shrinking, and Bigfoot is the very symbol of the endangered species. So endangered, of course, that he may not exist. And we're turning outward now from our planet and looking out. And this has given us these wonderful and vast mythologies,
Well, what about
for
the
good or
problem-
ill.
The problem of people not knowing what is real and what is not real when they watch movies, like Gravity. I'm sure you have some comment on Gravity, right? Which was extremely popular. And
George Clooney doesn't exist.
Oh, Lord. The worst is that I flew in space with a guy that is a bit like him.
Well, thanks.
Dave. There's a number of things. First, the question again of extraterrestrial, which comes a lot to astronauts, because they are a lot of people are very convinced that we saw things and we're not telling them because NASA has got some cover up and Roswell and all
Conspiracy.
this. So of course the answer is no, we didn't see anything, and then would be pretty sure that if we did, though, we wouldn't be the only ones, because there's a lot of people looking. I find that those extraterrestrial that do come and visit and abduct people are extremely discreet, because there are always only 2 people with a non-functioning camera in some forest that see them. Otherwise, nobody else see. I find that some of the science fiction is very interesting, because it portrays little bits and pieces. There's some fantasies, truly. Star Wars is a complete fantasy. It doesn't hold ground most of the time. But there are other science fiction movies or television programs that are a lot more based. I mean, Star Trek, there's a lot of literature about things that they were portraying, like wireless devices for communication, which today is a reality. They were doing that in the 60s, which is not completely out there. It is plausible, at least. And one of them, which is a fairly violent but interesting a movie, is District 9, where the alien ship parks over Johannesburg in South Africa, and is a kind of a mining ship, and has got an alien race in there. But that makes a lot more sense to me, the skeptic, that if there is somebody coming, that somebody will be seen by more than 2 people in the forest with a non-functioning apparatus. It ought to be that the odds of being able to come and not being witnessed is almost impossible. You'd always find that. But it's a lot of fun to look at what's happening in a movie. Nobody wants to go see a science fiction movie with me, because I'm always pointing out these things that don't make any sense. The ones that really break the fundamental laws of physics. Yes, Sigourney Weaver hanging on to a staircase in Aliens #3 while she gets rid of the mama alien by opening the doors to vacuum of space. God, that doesn't quite right. So then coming to Gravity, Lord. I didn't really want to go see it, and then there were so many questions about it that I finally saw it on a small Air Canada screens, like so many of us. And it's an interesting movie. I was a little bit sad that the female astronaut was a little bit crying and not portrayed as not being competent. So that I felt that they missed a beat there. It just changes a very enduring stereotype. But otherwise, there were a number of inconsistencies, but the people don't care. It was a good movie, and I find that people don't want to ask necessarily those questions. That's why they don't want to go see these movies with me. I see that in the phenomenon of the absolute fascination with the complete hoax, which is called Mars One, the competition to send people on a one-way trip to Mars in the next decade to colonize the planet, and having thousands of people apply, which the people who organize that are laughing all the way to the bank. But more importantly, and I must say, a lot of journalists, very serious, are interviewing those folks that volunteered to go to Mars on a one-way trip, a trip which, if they look at the current state of affair in transportation technology, landing technology, and survival technology, to go to another planet does not exist right now, today, and let alone in 10 years from now. And a TV reality, Roswell, you were saying that you'd like to see a geologist out there trying to pick out the right rock. Well, people are fascinated about the idea that we might, through a TV reality show, pick a crew to go to Mars, irrespective of their qualification or their ability to operate a spaceship, land one, and survive. But the thing is people are absolutely fascinated by UFOs and extraterrestrial, and having to colonize or going somewhere. And that is why we can send as many robots as we want. It's when the real human breathing person sets foot.
Bill,
that
you
everybody
reviewed dozens of movies.
Yeah, people want to believe, I mean, and I understand that, but there are two kinds of people. I mean, you've got your southern crackers, from the south, who like live in a small little remote place in the world, who, have been inducted. But then you speak to the people who are into Star Trek, some real academics, and if you question them, they talk about your arrogance as to thinking that how could you possibly think that in a we're 10 billion years old and there's zillions of planets that have been around. How can we possibly have the arrogance to believe that we're the only intelligent life form? And as you point out, you're not even sure that there's intelligent life right here. It's a fascinating question, but there are, it's not just, the Barneys and the Bettys who go off to New Hampshire. You go to Comic-Con or a convention like that and you'll meet these people who are academics, are intelligent, they've got degrees, and they'll argue for hours on end, and I'm sure all of you have met people like that as well. And I mean, they'll reproduce Star Trek and start saying, well, like you mentioned, how close some of this has been to reality and the likelihood, and they want to believe everybody. I mean, we live in a hopeless kind of state here because that, it's a vastly shrinking planet, so everybody wants to imagine that there's something far greater, far more powerful out there, and that we're just a speck, and there's hope in that, perhaps, or perhaps not.
When you review a movie,
Yeah.
do you even think about whether or not the science in it makes sense? Or?
I mean, it makes no sense whatsoever. I mean, like George Clooney, floating off in space with Sandra Bullock. I mean, she, as Julie says, I mean, she's got all these emotions that
would you point out that doesn't make sense?
Of course, well, you always do. I mean, E.T. was classic. Everybody wanted to believe in that Close Encounters of the Third Kind and all the rest. I mean, it's all fantasy, and everybody knows it's all fantasy, but the point is that there's a whole group of humanity who really desperately wants to believe that's true. I mean, you run into that all the time. That's why they want to go to movies with you, because...
Well, actually, I'd like to just switch gears a little here and just say, everything starts with a vision. And there are people out there who do not misinterpret, who take these things at entertainment's value, or
Right.
children, for example, who now it's planted in their brain that, going to Mars is possible. And they're not fixated on the fact that those particular groups won't get there, but those are going to be the next Elon Musks, or the current ones, who actually are going to figure out how we're going to get there. And so I'll say that from exoplanets, we have benefited tremendously from science fiction in any form. Because when I go and want to talk to someone or I meet someone, I don't say, well, here I'm going to explain, black hole astrophysics or the Higgs boson or the multiverse. I say, well, I want to talk to you about planets. And people kind of get what that means, and the thought that someday we may have a hope of actually going somewhere far away or sending a probe Now it becomes part of our consciousness in a way that it hadn't before. So for all the people who annoy you, I hope there's equal numbers of people who, take this in the right way.
No, they don't annoy me, I just think,
Well, I meant
I'm
like
talking
everybody, I
about the
wasn't
same
talking
kind.
about you specifically,
No,
but
but
I
I'm
find
talking
this
about
is,
the same kind of people you're talking about, who are academics and who, see the world in much larger terms, or the universe in much larger terms, as opposed to those who just say they've been abducted by aliens on their farm in Arkansas or something. And there's a huge difference in the.
well, there's everybody in between, so I don't want to not,
Yeah, no, but I'm
acknowledge that.
saying the way the public perceives these things is like, it's always black and white in our universe.
I see, I disagree on that, but.
I think I agree with Sarah in that there is essentially a cultural trickle down that comes from entertainment or even exaggeration, to be polite, that does affect ultimately the fact that 5% of a GNP or 1% of a GNP does get spent on doing the real thing. And we wouldn't have that. We wouldn't have that support in Congress or other legislative bodies in other countries without that cultural context that feeds it. I really believe that too.
Well, Sarah made the segue already to the exoplanets, which is the next little topic to discuss here, and the question of just what they are. Quickly describe what they are.
Sure.
And why there has been some controversy about their discovery.
Well, an exoplanet is a planet that orbits a star other than our sun, and I like to start by reminding all of us that every star in the sky is a sun, and our sun has planets, so we naturally would expect the other stars to have planets also, and they do. And astronomers have found, statistically speaking, that every star in our Milky Way galaxy should have at least one planet. And so that means if you go out at night, even if you're in the city, you can see a few stars. Although, just for the astronomers present, those are usually giant stars, and we're not so sure what's around those. But in general, you go out to a dark sky and look up, you can actually wonder what kind of planets are around those stars. And so that's very different from where we were, 10, 20 years ago. So I'm not sure what you mean by controversy. In any field, there's an error rate. Medical procedures, airlines. So exoplanets, we're not space travel. We're not alone. There's error rates. So out of all the planets we found, some of them are controversial and eventually retracted or they're fought upon. But I'd say one of the reasons why we get into that situation is because we're pushing the frontiers of what instrumentation was intended to do. We have the Hubble Space Telescope. It was never meant to find planets. Planets involve, if you will, making a measurement to many, many decimal places. And it just wasn't meant to do that. So when we push the envelope, we sometimes get into trouble.
What is the basic technology for finding an exoplanet?
Okay, well, there are so many. So I think I'll start with one that will lead us into a later discussion. And I'll start with the one that is the most popular planet finding technique right now. I like to think of it like the flavor of the month of ice cream. There's always, each exoplanet technique has its day, because it takes 10 or 15 years for investment in technology for one to get off the ground, so to speak. So right now it's transiting planets. Those are planets that go in front of their star, as seen from a telescope, and we don't see the star like spatially resolved. It's just a point of light. But by measuring that point of light very, very carefully, we can see a tiny drop in brightness, very small, 1%, fraction of a percent, a factor of 1 in 10,000. And that's actually the most common way to find planets today. Thousands of planets have been found with that technique.
Vicky, comment on finding exoplanets?
Well, so just to come 100% clean here, I am not an exoplanet finder. I am a neutron star observer. Some of the same techniques, though, the reason that I personally love the field of exoplanets and feel such kinship to it is because a lot of the techniques are so similar. For example, monitoring the precise speeds of some of the stars to see the reflex motion as a planet moves around it. You can actually detect that tiny motion of reflex due to gravity as a planet's orbit. We see the same thing in my research field and in many others in astronomy as well. I think when I hear the different techniques that are used for finding exoplanets, I find them fascinating. I just have to say that I know, for example, direct imaging of exoplanets. That's something that René Doyon here is a world expert at and can say a lot more about it. But there's nothing, these techniques of measuring reflex motion are wonderful, but in terms of for people on the street, for other to see it, and there's nothing like seeing an image. And some of the images that René has produced are really spectacular.
But all these techniques are complementary with one another, and basically the roadmap to life is basically two techniques. This is the transiting technique that Sarah described, and that's really the first one. Our humanity's first opportunity for finding life is with Webb, and this will be through transiting planets. So the other imaging, which is much harder, so it's just taking a picture, and we've done that 5 years ago. It was quite hard. It took about 10 years of work and trying to figure out how to do this. And, but we're not quite there to take pictures of a terrestrial planet. What we've done so far are, very hot gas giant planets, which are, much easier to detect. But I'm sure one day we'll get there. We'll be able to actually isolate a planet from its star, and we'll take a spectrum of it. But as I said, again, the very first opportunity for detecting life will be through transiting exoplanets.
Will the James Webb Telescope play a role?
Oh, absolutely. I'm building an instrument for CSA, which is one of the 4 science instruments on James Webb. And in fact, we've optimized our instrument to do just that, to take spectra of exoplanet atmosphere. So we expect
And
to be...
the question is, Renee, how much time will you get on James Webb with this great instrument? I agree with Sarah that everyone is excited about exoplanet detection.
Can someone just give a quick description of the James Webb Telescope?
Well, James Webb is a 6.5 meter telescope, so much bigger than Hubble. So it's an infrared telescope, so it works at infrared wavelengths. Hubble is optical wavelengths. Hubble is very close to the Earth, 400 kilometers, whereas Webb is 1.5 million kilometers away. So it's got a tennis shield size sun shield to protect it from the sun. So it's huge. It's got 4 science instruments, and it's going to do everything from finding the very first galaxies a few hundred million years after the Big Bang to study exoplanet atmospheres. But one thing very important to point out is that we don't know where to point this big bugger. We haven't found these targets, these exoplanets. So there's going to be a lot of missions, both in space and on the ground, to find them. And so it's going to be quite a busy time at the
Before
end
we
of
come
this
to
day.
that, let's back up a minute. So this telescope belongs to essentially, a few countries, but let's imagine it's a world telescope, and it's what I call like market value. People propose to use it. And so it depends what those proposers want. And people are constantly speculating, what fraction of the time is actually going to be used for, extragalactic versus exoplanets. One thing I can tell you is every single application I receive for like graduate student, postdoc, faculty, my main goal is to use the James Webb Space Telescope to find signs of life by looking at the atmosphere. So just the number of people who are going to propose, and even if all of those people have to get together and use all of their discretionary time and all the public time, I think it will happen. And the flip side of that, which is slightly more negative, is that the number of planets we're going to have to study, it's not going to be infinite. So if you imagine we have some handful of prime targets, I think we can get everyone to cooperate to really focus on those.
Yeah, you can estimate, the test team estimated that there would be maybe a dozen targets that we could look in detail, maybe each 100 and 200 hours.
Each one is like a Hubble deep field, essentially.
Yeah, and it
so
would
12
take
Hubble deep fields.
about 1% of the total time of Webb over its lifetime of 5 years. That's nothing.
When is what's the time frame for the James Webb?
2018, October 2018. And that date has been steady for the last 3 years. So count on it, it's going to be launched. October.
Joe, I think it's interesting. I'm listening with fascination. I know Lorne, you are too. We're both engineers, and I think that one of the coolest profession right now on this planet is to be an astrophysicist, and particularly to look for the exoplanet and to be in that search for a world that might be habitable, let alone inhabited, as you say. It's the coolest. It makes science, everything I believe, we're all convinced here that science explains the world that we live in. So it's cool everywhere. But this particular field, I must say, I'm totally jealous. It's a ton of fun.
Well, I'm jealous to you.
Oh, you'd like to run a science center?
No, I'd love to see Earth around.
One day you will. There are tickets going on sale and suborbital.
Okay, anything else you want to add about the James Webb Telescope? Anyone looking forward to?
It's gonna rock.
It is huge. If you like, NASA has photo galleries, and they're documenting, of course, the putting together and testing of the various components, and they had the solar panel deployed in one of the facilities in Huntsville, and it's huge. It's absolutely huge.
Speaking as an engineer, I would say the looking at this thing scares the bejesus out of me.
Me too.
I think it's
Failure is
probably,
not an option.
I believe it's probably by far the most expensive science instrument, or space-based science instrument ever built. The price tag is something like $8 billion. They call it the origami telescope because it is so damn big, you can't fit it into a rocket, so it has to be folded up very carefully. There's many, many parts, and it's very complicated. So unfolding this thing in space, 1.5 million kilometers away, it's a pretty risky proposition.
One day I was sitting at the science working group where the Northrop Grumman, which is the prime contractor for the telescope, and I asked a question. So they were showing some, the deployment of apparatus. I asked a question. On your list of projects, where is Webb on in terms of complexity? And he said second. So I don't know. There seem to be lots of things. Maybe that's just fantasy, but there seem to be a lot of experience in doing this kind of thing that we don't really know in the civil world. There's a lot of experience.
Yeah, I have heard that the complex folding mechanism of that there's American spy satellites, or I don't know, secret satellites built to the military that have to be folded up in a complex fashion like that, and it's that contractor that's responsible for this. So that gives me a reasonable hope that it's going to work. But still, you look at it, it's complicated.
Otherwise, it's not going to be repaired by astronauts anytime near.
No, but a recent X-ray telescope called NuSTAR also launched with a fairing that was about 1 meter and expanded in space to have a length of 10 meters flawlessly. And apparently there was lots of flight heritage. That means they had done this before for totally different purposes that we don't really know. So there is a lot going on out there that is not known to the public or to the scientists.
I was reassured when I saw the Mars lander. I was
Yes.
scared of that. This 7-minute terror, right? It's going to be 14 days of terror with Webb. That's how long it's going to take to deploy this thing.
I'll show that movie tonight to scare everybody again.
It's amazing.
Well, moving on to scary things. The reason that I thought that the Barney and Betty Hill story would be interesting to discuss is because it is a story that captivated the world when it was publicized, and it has a local connection because this couple was driving from Montreal to New Hampshire when they saw some sort of UFO and were abducted and tested and poked and prodded, and they still told their stories in books, and movie was made of it. And what is really quite amazing is how this captured the attention of the world with essentially zero evidence. So I think that's an interesting thing to talk about, is why did anyone pay attention to this story? Joe?
Well, I think I should maybe start off with this. I've met Betty Hill, and she's a very nice and was a very nice and interesting person. She was completely batty. She's just loony, but kind of wonderfully so, I thought. I think she's what's called a fantasy-prone personality, and that's a type of personality we've begun to understand. They represent maybe 4% of the public. They're the group from which we get the most alien abductees, we get most of the psychics, we get most of the people who personally talk to the Holy Virgin Mary, those types, the people who are seance mediums. And they're very believable because they, of course, believe their fantasies. They absolutely don't come off as, shifty-eyed charlatans who are out to do something. They're perfectly sincere. And I think spin a great story and disarm people with their apparent honesty. Their psychiatrist said that they were just sharing each other's nightmares, basically, and their dreams. But I've met many alien abductees and have done a study showing that great number of them are these fantasy-prone types. They have a number of markers. that we recognize. They're easily hypnotized, for example, and not everyone is. They are highly hypnotizable, and that's usually part of people discovering their abduction, is that under hypnosis they remember. And they're also given to these very powerful waking dreams, where you wake up in the middle of the night, but you're not fully awake, so you're in a state called hypnagogia, where you're between being fully asleep and fully awake. And in that state, you hallucinate. You may see extraterrestrials around your bed. And because many of the ghost sightings are of that nature, people wake up and see a ghost. They're obviously having one of these waking dreams. And so you wake up. So again, you're in an altered state of consciousness. And it can seem very real. The people who describe it have had a real experience. They've actually had something, they're not making it up. And because their body is still physically in the sleep mode, they feel paralyzed. They're unable to move. It's called sleep paralysis. And so they can then interpret this as that the aliens have them tied down, and then they see the aliens gathered around them. And so these are interesting things I find to study. I've studied them with psychiatrists and psychologists, and Betty Hill, in my estimation, was fantasy prone. I don't know about Barney.
That story got such traction?
Well, it told, of course, a remarkable story, so it gets your attention by just being an outstanding story. I don't know if people know, but the Betty Hill case was probably the first real image of the little big-eyed, big-headed humanoid. This is, I can't say that there wasn't that maybe in science fiction and so forth, but as far as someone saying that's what they saw, that's a really major milestone. And of course, that I'm going to show in my talk. I'm giving my talk now. Maybe we just won't need to bother with my talk. I'll just sum it up here, and we'll be done, and I'll be out of here. But I show something I call alien timeline. I'm showing kind of the evolution of these alien beings, and you start out with little green men and blobs and robotic figures and insectoids and so forth. But in 1961, you get this little big-eyed, big-headed humanoid. And that caught the public's imagination. And then my next slide is a picture of about 100 alien action figures and toys. And of course, that one has won out over all these others, because who wants to be an insectoid? Who wants to be a robot? But this one looks like us, only it's, of course, a futuristic version of us with, as we imagine we'll become, vestigial bodies, but huge brain case, big eyes, wrap around. And that was from Betty Hill.
Make a point here. I remember this from the original Cosmos with Carl Sagan. One of his episodes was Are We Alone? And he actually had a dramatization of the Barney Hill, whatever, that encounter. And one of the things that got their attention was a so-called star map.
Oh,
the
yeah.
claim that they do. And maybe you know more about it than I do, but it's
I don't know a lot about that particular issue, other than they had some dots which they could connect, and it was then said to be a distant galaxy.
Carl basically showed that this was just a random sort of dots.
It's basically confirmation
bias.
bias.
Like if considering the fact that they could choose any stars in the entire galaxy and they could produce this map, is surprising how badly they made the choice.
Yes, yes, exactly.
But can I ask the serious scientists here, if you guys think that you should get involved? When you hear stories like this, which of course scientifically make almost no sense, or do you just look the other way and say, well,
I'll just say that, first of all, I think for many of us here, it would be impossible to try to answer even we're not, in the field of entertaining these questions, but they just come to us anyway. It would be impossible to spend any amount of time on it. And they, like you said, the people are of a mindset where you can't change their mind. You can't apply logic to their reasoning, so it's almost impossible to do anything. I just try to make the statement whenever I can in every talk that I personally have never seen any evidence shown to me has never passed any test that I can imagine as being realistic.
But Sarah, still, my point of view on that is when people come forward with claims or stories, I say, show me the evidence, and I am actually willing to look at anything that they provide, right? Because if there is evidence, we should be looking at it.
Yeah, I say
I mean,
this,
I've seen
you
a
know,
UFO. It was an amazing phenomenon for the moments until I finally explained what it was. It's just amazing.
Yes.
Wait a minute, I'm a skeptic. This can't be
Tell
happening.
that story, it's a
So
good
what was
story.
it?
Oh, well, my husband and I were flying our plane from our observatory back home at night, and suddenly, we were under positive control, and suddenly there's this big bright light at 2 o'clock. It looked like the headlight of another plane coming towards us. But we hadn't been told about traffic, so we called up the controller and we said, what's at our 2 o'clock? And we get this, there's nothing on my radar screen. There's nothing there. But we're looking at this light. And yeah, well, after a while, the clouds that were there that we were unaware of parted a bit more, and we could tell that we were seeing the moon through a hole in the clouds. Right? So that became explained, right? But it was unexplained for a while.
It became an IFO.
Right? And so
That's
so
what it
people,
really, identified flying object.
so people see things. They see things all of the time, and
They do.
The mismatch here so far has been to associate them with anything to do with extraterrestrials or spacecraft. I mean, remember that for a number of years there were reports from pilots flying at high altitudes of bright lights above thunderstorms. Right? They saw something. Well, once we got remote satellite down-looking observational platforms, we suddenly have this whole new science of sprites and elves. It's possible for lightning to propagate upwards. So that there was something real, they reported
And if
it.
those clouds hadn't parted, we'd be having a different talk tonight.
Exactly, it would be really strange not
I'll
to
say
have
one thing though,
found the
if someone calls me who's very, very persistent, then I send them to the SETI Institute. But seriously, are you able to, you must get inundated with requests, like how can you possibly, investigate or comment on each one, or any number of them?
Well, first of all, send us the information, send us the evidence, right? That's usually where it stops. But when people do persist, we've looked at some very, very strange home video surveillance camera data.
My guess is you're gonna have people tonight waiting on the sideline.
I'm sure.
It happens at the conference you do.
Evidence is worth looking at.
I bet
Stories.
you'll have a half dozen people who come up to you, can I speak to you for a moment?
And I say, where's your evidence? And let's look at it.
Joe's the paranormal investigator.
Yeah.
You
I'll just say,
Well, right.
go talk to Jeff.
We do investigate paranormal claims. I have to say, I'm just one person, and I get this inundated not only UFOs but ghosts, crop circles, psychic phenomena. It's just endless, and I don't encourage people to call me or ask you to send someone tomorrow with his sighting. What I'm trying to do. And I had a fellow skeptic say to me once, he said, what you do is kind of a luxury because we can't examine every case. We can't look at all these things. And I said, no, but here's what we can do. And this is what I've tried to do. We can look at some of the best cases. We can look at some of the cases that get the most attention. So if something's on Anderson Cooper, and I know Anderson, and he told me once on his, he said, I'm really glad you're here, because he expected me to deal with this crazy phenomenon. So we do try to look at the best cases, the cases that get attention. I look for cases that I think are really interesting. So I'm looking for something that's not mundane and that might really yield something of interest, something new. And not just every case. I look at a lot at cold cases. I'm working now with a friend, James McGahey. He's a retired Air Force major. And he's unusual in that he's a former special operations pilot, which means he can't talk to me about what he used to do. And also he's an astronomer. And I bring him these cold cases and we work on them. And he's not a writer, I am. And we're producing some articles, some of you have seen some in Skeptical Inquirer, where we're looking at these interesting cases where, yep, something really happened. And what was it? Sometimes many years ago. And so we're going back and getting data, and he's been able to solve some by, in one case, because he was both an astronomer and a pilot. He solved one case. A person who was only one of those would have not solved it. He would have had a piece of something, but he wouldn't have had it.
May I add, Joe, that you asked the question, people who study this factually, why don't you interfere and when there are cases, but in particular for space travel, I'm coming back to that Mars One Oaks, where they want to send people on a one-way trip. I found that people did not want to hear the hard truth, that
No,
this is
that's
not
right.
going to happen. Then you can go out there and pretend you're going, but they wanted to hear the people who had volunteered and were selected to go, and they were asking them questions like, what are you going to say to your parents before you board the spacecraft? Well, he's never going to go and board a spacecraft in 10 years from now, so it's pretty easy to volunteer. But so what I found in this particular case is that when they would hear my factual arguments, then there were some technical issues to be solved before anything would happen. I get 5 minutes of airtime and they get 30 minutes of airtime because they are fascinated by the human story. They would like to hear the stories of the abduction because they're a lot more fun than the hard truth.
It sells more
Better
newspapers.
TV.
Yeah.
Well, this is
And more movie tickets.
this is very true with all
Everybody's
these.
gonna be attracted to that kind of story.
You know, these TV documentaries, or I sometimes call them crocumentaries. And I'm the very token skeptic on a number of these, and they want the skeptic just to sort of add a pinch of, a little pinch of strife or something in the story. I've had examples where I was allowed a couple of moments to sort of rant, rave, hold up charts, whatever. The rest was edited out. And then one of the crazies would be put on to refute me right afterwards. Never the other way around, you see. And we used to even ask whether it was to our advantage to be on some of those shows. I used to refuse to be on some of them, but when I took a job doing this full time, I could hardly do that, you see. And we follow sort of the idea that that a little bit of skepticism is better than none at all, though it is sometimes debatable. But we do try to, our organization, Skeptical Inquirer Science Magazine, and we do try to look at these things and to be a voice for science and reason on television shows and elsewhere, and to speak up for the scientists who really do have better things to do. Carl Sagan was one of our founders, and you may remember the entertainer Steve Allen, who was a dear friend of mine. And we that's our mission, to try to look into these speculative areas. But I found, the miracle people will call in or send in things, and they're going to pray for me, or they feel sorry for me. But I've had the UFO and ET people just shrieking nearly hysterically, and death threats and that sort of thing. They're just a different bunch almost, I think.
I actually have a question for you. So you've been doing this, I guess, for
40 years probably.
Right,
My
and
first
so-
case was 1969.
So with the introduction of the internet and the ability for people to communicate so much more easily and to get information and to post information,
Yes.
has the number of these kind of claims increased or decreased or just remains stable?
I don't have any data on it, but we're not. There are some people who used to say, we're through investigating these. Say we finally solved, spontaneous human combustion, and we finally solved. We know what UFOs are. We've finally done this. We're out of here. No Bigfoot. And of course that's not true, because what happens is the next generation is already unaware of all this, that the Bermuda Triangle mystery was solved. They didn't get the message, so they're now reading about it, rediscovering it, and you have to teach all over again. Plus, there are new claims coming up daily, And so the skeptics are just not able, and it forces skeptics, this is where it's a real problem, it forces skeptics almost to become sort of knee-jerk debunkers, which I refuse to do. I'm a former detective, so I actually want to take a case and solve it. And some people say, yeah, and while you're doing that for 6 months, others are coming in over the transom. And so some skeptics are just debunking and, saying anything that they can, like, yeah, those people are probably crazy, or that she's a liar, or something. And I just don't want to be a debunker. But it is endless, and I think we won't solve these mysteries ever. I liken it to putting out forest fires. We dampen some back, we save some homes, and we try to save our civilization as best we can from the craziness, but we're not going to ever
All right,
stop.
Because, like, you brought up the internet, which I think is an incredibly important point, because this stuff is there and it never dies and it proliferates, and it's the kind of thing people want to read because it's more fun than reading the real stuff. But we really have got to work on our young people about critical thinking skills, because as this becomes their primary information channel, they've just got to learn. They all need the baloney kit, right? They all really need to have a sense of, does this make sense? Right? Is this real?
And of course, the first things that come up on any kind of internet change are the baloney things.
Right.
And you have to go deeper and deeper to get the real science. Anyway, let's get back down to Earth. Next
Sort of.
question
Why?
about
Sort of.
extraterrestrials.
Sort of better.
Yeah, okay. So how about that? What do you really think will be the first sign of extraterrestrial life? Will it be a radio signal? Will it be a microbe somewhere?
Crash saucer.
Been there, done that.
Right.
It's either biomarkers or biosignatures. Biomarkers, some kind of isotope ratio from a sample from Mars or Europa, or biosignatures from afar.
Now, when you say biosignature, that raises the question. We think, of course, we're looking for life the way we understand it. So, of course, we're looking for the signature of life the way we understand it. Now, it could be that life is also in different shapes and forms. Could it?
Well,
or is
yeah.
that something that is completely out of question from
No, I mean,
scientific
we
research?
acknowledge that we're assuming that life is based on chemistry like we are,
Yes.
and that life
That we
uses.
can safely do, but is it based
I don't
on
know. I mean,
carbon and nitrogen?
It doesn't
DNA
matter.
based?
I mean, in
Is it
terms
DNA
of,
based?
for astronomy,
For sure.
we're just looking for signatures produced by life, and we're assuming that life stores energy, chemical bonds, and releases chemicals. And there could be other types of life. There could be life that uses mechanical energy. Think like a windmill. We wouldn't be able to detect that at all. So there could be life that exists in Europa-like states underneath the surface that astronomers can't detect remotely. So when we're talking about biosignature gases, it's very limited for sure. We just hope that life is ubiquitous and that it's maybe a little naive, but it's optimistic.
Well, I mean,
Life is
that's-
ubiquitous and will produce gases that we'll see, whether it's carbon-based or something else or some shape or form. We can't access that.
Right, but in the community what is a mostly accepted theory? Is that it's probably common, or is this something we really don't?
Well, it's
No,
the
yes.
only thing we can do. It's the only thing we can detect from afar is biosignatures. It's something that produces gases on a planetary scale that we can detect. Some abundance anomaly that you just cannot explain through thermodynamics.
Well, because you've built an instrument that's going to go on the largest telescope ever built, it's because you believe that you have a good hope somewhere to find
Oh, but
that. Otherwise
that's faith.
it's just that.
Yeah,
It's hope and
yeah.
speculation. We have no evidence
Yeah.
that there is life beyond Earth, actually. I think that's why Jill started out by saying if we find some other sign of life in our solar system, then the world is open for us, because we know it has to be very common. So right now it's just faith. So the way that I actually try to put it, when I don't speculate, I always love to speculate, but first we just try to be serious. I just say we will have the capability to detect it if it's there.
But we might not recognize it. One of the problems is that I'm looking for technosignatures. I might not be looking for the right things. Maybe we haven't invented the technology that's the appropriate one yet. We're looking for biosignatures, but we don't really know what those are. Right? And they will certainly, over the evolutionary history of a planet, they're likely to change.
And they may be there and we just can't identify them. Like our own Earth, if you ask about the gases in our atmosphere, most of them, to the part per trillion level, they actually are produced by life. They also exist on their own, like N2, CO2, all those gases, they're actually produced by life, but they're also already there. So it's a whole very complicated topic, and we haven't reached an agreement on how we're going to sort through things. We're just fixated on getting the capability and getting data now. And there's a huge other body of people trying to sort through things.
The astrobiologists have looked at the question of other kinds of life, not carbon-based, et cetera. There was a conference, a Weird Life conference not too long ago.
The National Academy put out a Weird Life
Right.
report.
And, and one can imagine different ways to combine elements, and, there's the Star Trek solutions, it's silicon-based life forms and all that. But, the ubiquity of H2O in the universe and the other common elements that make up the chemistry that we're based on is kind of an Occam's razor argument that there's a way to do it that one place in the universe has figured out how to do it with common materials that are common everywhere. And so it's not just guessing that life like this could be elsewhere. It works logically from the way the periodic table works and chemical bonds and our basic understanding of physics and chemistry, and it has to work here on Alpha Centauri and on the Andromeda Galaxy. It's the same.
Anyway, we don't have to go away from Earth to see Weird Life.
That much is true.
No,
I live in Berkeley, we see it all the time.
It seems that was Jim came back to one of the most interesting questions, which is what's the starting point for a lot of the research that's done? Is it that life on Earth is anomalous, or is it that life in the universe is ubiquitous? I mean, and so if you start with those principles, which one of those two, you can still do the same science and come up with an answer or supporting evidence that says...
We admit that in the field I work in, we acknowledge that we're very limited in our thinking and that nature is probably more creative than we are.
Mm-hmm.
But we start by designing our instruments and thinking about terrestrial-based life. And we have branched out, actually. It's just very challenging to do. What if there is another part of the periodic table that is being used for central biochemistry? It's nearly impossible to describe that. So we try to do both.
Did anything, this is, again, as a non-scientist asking a question, but does anything in the experiments that have been done at CERN with regard to the Higgs boson give us any evidence? If the multiverse had proven true instead of similarity, would that have made any difference to what we're looking for?
No, I think it's interesting to think about things like that, but no, I mean, the topics, what people are talking about in terms of searching for life are really based on physics that we understand pretty well. It's physics and chemistry and the Higgs boson, that's a whole other thing. Now, could you imagine some different universe where things work totally differently? We assume the laws of physics,
So it's not just
are
the
common.
laws of physics, the laws of chemistry, biology, all follow sequentially, and therefore we're looking for something that we would be comfortable identifying as life, so recognizing it would be based on...
I think we acknowledge that if it's so far beyond what we can acknowledge in our brains that we're basically unable to identify it right now.
So on this planet, we try and look for the limits of life. And of course, extremophiles have been a fantastic boon over the last couple of decades. Life that we totally believed impossible. So we look for the limits of life, and we're at the point where we get to parts, for example, in the Atacama Desert, where it gets so dry that we think maybe life stops here. But we really don't know whether it's the fact that there's no life or that our detectors are insensitive enough, just not sensitive enough to find the life that's there. So this idea of weird life that uses different biosolvents or different metabolic paths than the life as we know it, could in fact be on this planet.
So just another naive question, sorry, but if we only have one species in the numerator, and as you keep finding, as scientists keep finding more and more life forms in the extreme, don't we just add to the denominator and make it less probable that we're going to find life elsewhere?
Well, all of the life that we've been finding so far, these extremophiles, they're all life just like us,
yes.
right? It's all based on the same thing.
But
so
that adds to the denominator of how many species exist, and we only have one in the numerator.
But everything that we're using to look for life is based on life as we know it,
okay.
right? That's the problem. The instruments that we built assume it's life.
And one very important point is that life on Earth at least life as we know it, has been here for billions of years. And that's what makes it very encouraging. And you know, life has been affecting our atmosphere for that long. So that makes it very encouraging to find it if that process gets started elsewhere.
Or just as an amateur, I would second a little bit what Jim was saying, is that the basic chemical building blocks of life are amongst the most common elements in the universe. And so it's pretty likely that out there are planets that are in habitable zones that have liquid water, that have oxygen, and so on. If we found such a planet, which capability exists, the instrument that Renee is building for the James Webb has the capability of making measurements like that. Found a planet in a habitable zone with water and oxygen. That would be a pretty suggestive thing. More sensitive instruments may be able to detect rarer gases that would be sort of what they call disequilibrium, like methane. And if we found those things, it would be an even stronger signal. So those are things that are quite plausible and pretty likely. We don't have to think too exotic. We're very likely going to find planets like
Now,
that.
there's also the question, so let's say James Webb, it unfolds in all its splendor and works beautifully, but you see no biosignatures in the end. And so I think probably from that you would not conclude that life is not ubiquitous. On the other hand, let's say you flew to Europa and you could drill down into that ice and scoop some of that back, and maybe that's not going to happen in the next 20 or 30 years, but it could happen.
Or fly through the plumes if they really turn out to
Right.
exist.
Now, what if you didn't see any life there? Would that be surprise? Would you scratch your head at that point, or
Exactly
no?
the same as the Webb story. Lack of evidence of it in one location is not generalizable.
And it may be life that just operates so slowly. You know, like here on Earth, there are places in rocks or in the ocean where life only divides cells like every other year. So it may not actually have enough output to detect. But I always like to think of Mars. I always use Mars as examples that people will look for signs of habitability and signs of fossilized life or real life subsurface. They'll keep looking. And they went there, they go back, they're going to keep going back. So we'll keep at it.
What do you think it would do philosophically if some form of life were found, let's say on Mars, concrete bacteria, no doubt about it, if they're there? What would it do to religious philosophy?
Something I think, is going to change the world, but nothing will happen.
Organized religion has been around a whole long time, Joe, and it has incorporated a great deal of change in our cosmological view of the universe, right? It seems to be pretty flexible in terms of
And there's
reshaping.
plenty of modern religions that would have no problem with it, actually.
I have a joke for you guys.
Others would.
It comes from one of our colleagues, Seth Shostak, when he came to McGill a few years ago. He says, we're looking for these signals from these alien civilizations. And I bet you when we get the first one, it'll be a religious station.
Absolutely.
Okay, the one about President Obama. We all heard this, his pledge to land someone on an asteroid by 2025 and maybe Mars 10 years later. How would you rate the probability of that happening?
So I'll start on that one. It's, it's always, first of all, it's always good when the leader at the top is expressing an interest and a vision for something like science and space exploration. So that's a good thing. And he's not the first president to do that, of course, in the U.S. The issue always is the follow-up and providing not just the short-term vision, but the long-term funding proposals in the budget and the support needed in our Congress to get that funding approved. And that has been a big problem since his speech in 2009 on this topic. Whether that specific plan comes true or not, one important part of that plan is the infrastructure to do it, right? So I love the space shuttle. I grew up with the space shuttle. It was a great vehicle, but it couldn't go beyond low Earth orbit, right? The space station, spectacular facility. If the Earth is a basketball, you put a dime on the basketball, and that's where the space station is, the top of the dime, right? And that's not deep space, right? And so I was actually really happy to see NASA get out of that business and try to look beyond. And to do that, they have to get a big rocket, right? And so the development in the U.S. of the what NASA calls the Space Launch System, the SLS rocket, to take large amounts of mass off the planet and into deep space, to the moon, to Mars, to asteroids. That's absolutely essential infrastructure that's enabled by this pledge. And so whether the rest of it comes true or not, I think there's a lot of support for, let's get the capability back. SpaceX is developing a large heavy lift vehicle as well that could also provide that capability. So there's a lot of skepticism about whether this specific plan will be followed. There's no actual budget to do it. But I'm encouraged that some of the infrastructure is being put into place that could make it possible.
But you would say no by 2025?
I'm skeptical. I'd love it to happen, but I'm skeptical.
Anyone think it's going to happen by 2025?
I always like to quote my golden rule of instrumentation. It always takes longer than you think, even when you allow for the fact that you know it's going to take longer than you think. It converges, but it's, you know, it's at the end of the day, it's a funding problem. It takes a lot of time to raise that money and get everybody to agree to do it, and it's tough.
Well, let's say right now, if the funding were available, could it be done by 2025?
Absolutely.
Absolutely, but it's not going to happen.
Yep.
And we call it in the astronaut world Kennedy 1961 syndrome. And I absolutely agree that we can't, especially the top nation in space with the Chinese trying to catch up very fast behind are the United States and Russia. And in the United States, for having been in that world for 22 years, every president that would come would have to say something significant, because that's what Kennedy did on top, and it galvanized the nation and did an enormous program. The reason I wanted to join the crews and go and become an astronaut is because I saw the Apollo mission in my school here in Montreal. I didn't understand what they said because I didn't speak English at the time, but it didn't matter. It inspired a whole generation of people to go into science and technology, to go beyond and to live a dream. So this is fantastic. But so we saw various presidents come and say something. The one before, Mr. Obama, wanted to go back to the moon, which most of us believe is perhaps a better investment of time and money, because it will allow us to build technology to go further and to develop nearby techniques to survive somewhere else. So you think that the asteroid is not going to provide that particular testing bed. But it was difficult maybe to pronounce that right now politically, so in 2009 particularly, because it was at the beginning of the before the re-election. So we think that it might be possible. If the money's there, we'll do it, because it's a great show of know-how and technology. We've just had a little probe, I don't remember the name, orbit around the comet just a couple of weeks ago, Rosetta, which is a great achievement. So we could do it with the proper money. Is that the right thing to do with the budget that they will have at the time? That's the question. Also, 2025 is an interesting year. It's the year when we will reach typically the end of life of the International Space Station. And what are we going to do with that? When Mir, the Russian space station, ended its life, we had a controlled re-orbiting or deorbiting of the station and into the southeastern China Sea. What are we going to do with something that's the size of a football field? So it'll be interesting. Things are going to change till then. But by then, you guys will have found a habitable planet with gas.
So I'd like to add something, actually, because many people actually aren't, all the many people who are skeptical of NASA succeeding, we actually always have hopes. We have hope in the Elon Musks of the world and the so-called private commercial spaceflight industry that someone will actually take risk and figure out how to get there. So I think it's going to happen. I think someone else here had said before, we're going to go there sometime, somehow. It was you, actually. And it may just not happen through NASA directly. Indirectly, it will.
So Jim, earlier on when you said someone's going to go there somehow, somewhere, one thing that didn't get brought up is this idea of Earth as a single point failure and moving off the planet because it may be the only way for the species to survive ultimately.
Yeah, we got to get off this planet.
That's interesting, because I have a complete different view. For having been off the planet into a spaceship, which we take care of meticulously, where no decision is ever taken by one solely if it's critical, because we know that the air is human. If anything, this was the only place I could go back to, is that planet. There was no way I could stay in space and live in there forever. There is always, and everything we brought with us was from here. So I didn't look at it as a single point failure, but as a
Just
whole.
thinking long-term.
I understand.
Long-term.
And to me,
Yeah.
the idea that I have, and I tried to share a lot with people, is that why don't we treat this planet of ours like we astronauts treat our spaceship?
Mhm.
It is,
Here, here.
if it is indeed, there's a lot of systems within the space shuttle that were single point critical. Yeah, if they failed, we were done. So why don't we make sure that we take care of our planet? Because yes, it is right now, until you guys find the others, we can live on it.
Well, that's almost a good place to stop.
Mhm.
But
Wow.
just maybe a couple of words from on the last one. Where would personally, what would you like to see as the next step?
So I think I agree with our host Lauren that we're seeing a real sea change in exploration from the private sector, from the commercial sector, and that's just going to continue. I like the fact that this low Earth orbit arena is going to become an economic sphere for companies on this planet. To interact with each other, to interact with governments and NASA facilities. The International Space Station as a research laboratory needs to be resupplied. Somebody's going to take out the garbage. Somebody's going to want to take tourists up to orbital hotels. I want to go to the moon for the weekend. Told my kids that. Hopefully they'll work that out for the future, some future birthday. And that's all coming, and I think that's great. And that part of that, I'm hoping, will help the space exploration enterprise by decreasing the cost to launch, by increasing the efficiency of vehicles, by providing large launch vehicles that scientists who want to send probes all over the solar system can use without having to pay for an enormous ancient government rocket. And so that's going to be a big change. At the same time, that will compel space agencies like NASA to be forward-looking, to be frontier-looking, to be pushing the boundaries of exploration.
That's what you would like to see, is more privatization.
Yes.
Sarah?
I'd like to see the next step to be taken, whatever that is. We can't wait around forever, and if someone can show they can do the next thing, whether it's sending a human to Mars on a more risky mission than we conceived, or sending an interstellar probe that may take forever to get there, I think we need to start something.
Let's do it.
I hope we do something even if it's wrong.
Actually, I'd like to see us really think about the consequences, for example, of mineral extraction from asteroids, mining space. Imagine, if we think about that, how that will rewrite the geopolitical map of this planet and change the dynamics of the places from which minerals are extracted and the places in which they're used. I mean, think about it. Ultimately, if one doesn't create another exploited class in space, this using extraterrestrial resources could in fact alleviate an enslaved population on this planet if our resources begin to come from someplace else. I'd like to have us begin to think ahead, to think about, okay, suppose we find life on Mars and there are Martians there. What are our ethics? What are our relationships to those Martians? What is the law of space versus what we're trying to put together here? Just take on some of these long-term challenges and think about them systematically. I like to talk about the megacities that we're going to have here in the 21st century, cities with more than 20 million populations. I think we ought to be thinking about those megacities as starships, as these enclosed life support systems, and how to manage them well so that we can reduce the pressure on the planet. And lastly, I'd like to go back to question number 8, because I'd like to claim that there is probably a decade, 2 decades, maybe 3 decades, before these technologies that will allow us to perhaps find biomarkers or biosignatures are developed, where maybe we might actually find a technosignature first.
Well, thank you all very much, and because, I mean, this discussion is really aimed at the intelligent layperson out there who's going to be viewing this, as I said, all over the world, maybe we can leave the final comments to our two intelligent lay people here and ask you if what you knew before about space exploration has changed. You know, has your mind changed about what you knew before?
Well, it's fascinating stuff. I mean, but it's a lot of what I had heard and known a little, but to listen to these experts, it brings it to a whole other level. But they're wise to say that the only hope for funding for exploration will be private, because the first thing any government will do any time is get rid of funding for like any kind of space exploration, because when public starts clamoring about health or war or everything else, I think that's the only hope. But I'm also worried about an asteroid hitting Earth and destroying all of us before.
Karen?
I would move to.
Yeah, it was really fascinating, actually. I guess I still, and it wasn't necessarily this topic, but still wondering if the universe is finite, what's on the other side, and if it's not, how can anything be that big? So I guess.
Well, I think that's a topic for another.
Yeah.
What
Yeah.
happened before?
Okay, well, thank you all very much for the discussion. And for all of our listeners who are viewers, watch this. You can look forward to watching the actual symposium, which also will be recorded.
Thank you for the provocative questions, Jay.
Yes.
Yes.